Okay, elc138, worksheet 20. Okay. This had some Festo stuff on it. I think this is the last worksheet where we would have used the trainers. And you own the relay coil. And you should get something when you own a relay coil. There are very minor exceptions, and that have to do with how well your meter reads resistance and how much resistance a coil has. But generally a relay coil will have some resistance. I can't give you a number because there's different coil types out there. They're made different ways, so the resistance will differ, but they will have some resistance. If you ever read a relay coil that has an open, then it is probably bad, and that is in fact one of the tests that you make on relay coils, is you ohm them out to see if they are in fact open or zero or infinite resistance, not zero. Ohm the normally open relay contacts. Ohms of a normally open relay contact should be open. Ohm and normally closed relay contacts, the ohm should be very close to zero. They're never perfectly zero. Connect a switch control circuit with an ammeter to measure coil current. Measure the energized normally open contacts. When you energize a relay, the normally open contacts change state, so now they are closed, so the ohm value should go low, near zero. And when you energize normally closed contacts, they should open, so the ohm should go to over limit, and your coil current, you should be able to measure something if it is actually moving. The other thing you can see about a relay is you'll actually see them move. You can physically watch them move. Okay, and it says build this circuit, predict its operation. So if you were to build that circuit, what you would see is that when you first turn on the power, indicator light B would be on because there's a normally closed circuit. In other words, there's a path there, and that's what relay contacts show. They show current path. So your ammeter 2 would read, and you indicator light B would be on, and that would be what would happen when you first powered it up. Now when you push that push button, you will energize the coil, the CR there, and when you energize the CR, the contacts above the lights will change states. So whenever CR is energized, the contacts above light A will close and light A will come on, and the contacts above light B will open and light B will go off. And so it's actually not a bad circuit to see. Push the button, lights come on, lights go off, and they change states. One of the biggest things in industry and in doing maintenance is how do relays work. And the more you understand how relays work and the more familiar you are with them, the better off you'll be from a maintenance standpoint. Okay, I went down. I should have scrolled. Alright, then we change and we predict this operation, build this circuit, and predict this operation. I did not miss one, did I? No. Okay. So we're taking out the push button switch and we're going to a toggle switch, and what you will see is with the toggle switch open, your red light will be on and your motor will not be running. Your green light will be off because of the normally open relay contact above it. When you close the switch, then your motor will run and your green light will be on. So basically your green light will be on when your motor is running, your red light will be on when the motor is off, and all that is switch controlled. Okay, so that takes care of those. Draw the Thevenin equivalent circuit to study a 5K in the following circuit. I got 14 volt supply, 2K in series, splits into two branches. Branch 1 has a 5K and a 3K in series. Branch 2 has a 6K. The branches rejoin and return to minus power. For the same circuit, draw the Norton circuit for studying the 3K resistor. Okay, I think I've got a video on that somewhere else. I'll probably make a separate video just on that. 12 to 16 is fill in the table from the following circuit. So here's a different circuit. It's not the same circuit as 6 to 11, and I just want the current through and the voltage across. That is straight circuit analysis. Voltage drops, current throughs. So we'll do that. We'll come back and revisit 6 to 11. What advantage does a relay give? And a relay allows for a lower current to switch a higher current, and it controls whether voltage is either on or off. What are the components? You have contacts, which consist of normally open contacts, you have normally closed contacts, and you have a coil on a relay. When are the normally open contacts closed? The normally open contacts are closed when the relay is energized, and the normally open contacts are open when the relay is de-energized. And the opposite could be said for the normally closed. Normally closed relay contacts are open when the relay is energized, and they are closed when it is de-energized. Okay, they got to find that Thevenin circuit and walk y'all through that, or make one. That's probably what I'll do. Anyway, that gets you through most of worksheet 20 except for 6 to 11, and look for another video on that. Thank you for watching.